starting now. This is going to be the start of just a live stream series. I'm working with Rust, Direct3D12, and building a graphics engine. I'm using some things like Bevy ECS to sort of help me out along the way, but my focus is on like the graphics coding and building modern renderer. I've already made quite a lot of progress on this, and I've been working on it for a while. I've written some blog posts about it. You can find that on my website in the links. Social links and channels are available all over the place. Just find me at Polymonster, and Polymonster without the E on Twitch, but Polymonster on most of the things. And I'll give you a little rundown of where I'm at now and start going into some work. I've got basically a bit of time between now and like a month's time or so starting a new job. So I thought it'd be fun to do some coding. So I'll just build and run. Right, so here it is. It's like a live coding tool. You can edit Rust code, hot reload it, as well as render configs, pipelines, render graphs, and all that stuff in data files. So I'll do a little demonstration about that, but first I'll just show kind of what I have. I made all of these primitives by doing hot reloading and kind of, making sure I get nice as possible UVs as I can be bothered to deal with. So that looking all right. They got normals and things like that. So that was kind of the first little thing I've done. These are just basic tests, and I'm implementing graphics API features to back it up. So this is just a single draw indexed. Then there's a draw indexed with push constants to transform each draw call separately. Here's an instancing draw call where it's a vertex buffer using the vertex shader stage, step rate, and instance per instance step rate. Then I've got a C buffer one, which is kind of indexing into a C buffer based on the system value semantic instance ID in the shader. And then this was the next thing I was starting to work on, draw C buffer material. So I was going to work on a material system. Like I said, I was using Bevy ECS. So this is a schedule, Bevy ECS schedule. You can register and create setup functions, build a render graph, and this doesn't have any update, so actually maybe geometry is better. So we have a setup which can spawn these entities, then we have an update which rotates the meshes, then a render graph which is specified in separate configs, and then this is the command queue of how it gets rendered, because there's actually extra passes are inserted for barriers and transitions. Some kind of debug info of the kind of resources we have bound. That's a little bit cut off there, but that's sort of this is called the hotline client, and it's not really an editor, it's just a way to kind of debug and display information, and most of the editing is happening in code or in render configs, which uses a system called PMFX, which I'd worked on for quite a while now, and I'm updating it to be more modern in terms of its outlook on graphics. So I'll just do a little quick demo of where I'm here. So what I was working on is to draw C buffer material. I was just hacking this sample actually to debug something, but I originally had, so it's built, I've changed the code, it's built, took about 5 seconds, which is kind of roughly how long it's taking at the moment. I'm using LLD, which gave a slight boost, a more consistent performance, but there's still a 5-second kind of cost of compilation, which isn't too bad, but it's also just slightly prohibitive. So any Rust code inside plugins, and I have 2 plugins, I've got ECS and ECS demos. The ECS plugin is like a core thing which is going to have, or it has some shared functionality that many different plugins might want to use, and then the ECS demos are more like these tests basically. And it also actually might be worth pointing out, I've got this, like, this is just a test of raster states, a test of blend states, and then some tests of like missing things, just so it doesn't crash basically. And yeah, just just so it doesn't crash, and so that if you're editing and adding stuff, you can sort of safely do that, and it will tell you what you're missing and what you're doing wrong. So the plan was to make materials, which are sort of going to be hooking heavily into, let's see, the PMFX system. So these are like config files, basic HLSL shaders. This is the checkerboard shader that's being applied here. The checkerboard's actually calculated in code. It's not a texture. But I can edit these. Say if I add this, it debugs the U gradient, or I can debug the V gradient. And I was using this to make sure my meshes have nice UVs. But this is responsive and feels nice, and like I just wish the code reloading was that fast. Maybe in time we'll get there. Maybe in time Live++ or something like that will come along for Rust and solve all of my woes. But in addition to HLSL shaders, we have this config, PMFX config, where you can specify render states. So I can create a pipeline. It's called Mesh Debug. It uses a VS and a PS. I've said it's got some push constants. I'm specifying depth stencil state and raster state. So if I do something like, let's make this noticeably do something. So if I change the raster state to call none, which is a raster state that's been defined in another file, that kind of nicely works, and we'll put it back to call back. If I go into this other config, which is imported hotline.pmfx, this has some this has like the raster states in there. So there's call back and call none. It's got this wireframe where it's applying a depth bias, so it's always going to draw on top. If I make that changes, maybe it didn't. Oh yeah, it is working. It might be hard to tell on the screen depending on the resolution. It just applies a bit of a depth bias so that the wireframe draws on top. Let's make it really extreme. It's completely gone. Hopefully that's visible. And I could, I could change the callback state to change it to call none, or actually call front might be a bit more noticeable. Right, so we're changing to front face culling. And then we've got blend states. That you can edit those just the same. I mean, maybe give it a quick test. I don't know if I've actually tested the blend state fully, so this might be interesting. Additive. Let's just disable the additive blend. So I think this one here is additive. Oh, right, that didn't work. So that's something to make a note of. Double check. Yep. Okay. So I think blend states are not. Oh dang, that's fine actually. PMFX blend state, not hot reloading. I think maybe I'll be able to do another thing just to debug this slightly. So these ones are called pipelines. Okay, blend additive. And if we change the blend state entirely of blend additive, let's see. Right, okay, so that's blend state additive, and now it's worked. It's just like it knows the blend state has changed, but it couldn't detect that the contents of the blend state had changed. So that's a hashing issue. Which is fine. So I need to just hash the entire thing. I got this to-do list of all stuff that I'm working on or planning to work on, and I've also kept a history of like all the stuff that I've done. I've been working on. It's probably about 18 months or something in total, with a bit of downtime in between. So yeah, finding the bug. I'll have a look at that. Not just now, but it's on the list now. So back to, and then let's go back to C buffer material. This is just kind of like an empty or basic start of that of material system, which I'll talk through shortly. I'll sort of start digging into actually implementing that, and you get a better idea of the workflow. So in terms of kind of render state, that's all fairly self-explanatory, I suppose. I actually want to go into hotline PMFX. But we also have in here, you can define textures. So this one's called the main dock. And I can do things like I can change the scale. So it's linked. This main color texture is linked to the window, the main dock window. Now you could link it to the entire main window or any other windows you have in the system. But I could hot reload this, and that's downsizing it to 0.25, 0.125. You know, obviously you might want to do that. Tie the ratio to a render target size for kind of post-process effects. Sometimes you want to do dam sampling. So that's quite handy. This samples doesn't need to exist because main color, main depth inherits main color, so it will get the same sample count. So I'm just going to update that. They've reloaded. Nothing's really noticeable, but I can knock them down to a single sample. Might not be that noticeable, but on a compressed stream, but the sample count's changing. And also this one, I can even do like R32F, for example. I changed the render target format entirely, which is quite nice. And then going beyond textures, we have views, which are view is like it's starting to build into the ECS a bit. It's like a render pass, but it has a camera. And this is the main view, which is where we are now. It has a clear color specified in here, so I can just change that, and that looks like a normal map kind of. So I can change the clear color. I could change the camera, the viewport as well. Let's see. Let's see if we do a 0.5 viewport. Oh, that's not working. Okay, some of these things I just hooked up and hadn't like tested the full permutations of it all. So that's another thing to try. I can change the clear depth though to 0. This is going to make nothing render. So yeah, views. And then what else do I have? I think there's, oh yeah, there's render passes. So render graphs, sorry. So I've got render graphs, they're defined in the debug config. Mesh debug, which is, I'm on mesh debug C buffer instanced. I'm drawing a grid. I'm drawing meshes. Am I? No, I don't think I am yet. This has been added there as a placeholder for this particular example, but I'm pretty sure I'm still using this. So here's a render graph, you know, basically saying there's grid, there's meshes, there's wireframe. That's the 3 passes. They are also here. So we call the render meshes function twice, but with different pipelines. And there, see how they've come out in a different order to how they're specified, because this gets converted to JSON, and that's not, you can't guarantee the ordering of keys. And then they get put into correct order here with barriers at the start and the end, and these dependencies determine that. So as time goes on, that's going to definitely get more complex. These are all dispatched onto different threads, so the command buffers are generated asynchronously on the CPU. But I can do stuff like this. I can remove a complete stage here. That one depends on grid. And then that's gone now. You know, I've only got the wireframe, so quite a lot of flexibility there in terms of data editing and code editing. And it's been quite fun, you know, to get to this point. I'm only working on some basic demos, but in time, I hope that that should be able to accelerate. I've also got tons of HLSL shader code and already examples from previous code bases, so I'm hoping like it's it's going to pick up pace, and I can cover quite a lot of ground during this stream essentially, or series of streams. Okay, so basically that's a rundown now, and I'm going to get on to kind of where I was up to. So like I said, I had the to-do list. These are just some kind of bugs I'm going to put in. PMFX viewport. It's not hot reloading. I'm not going to look at those just yet. They're just their notes for the time, but material was the thing I was working on, and I was loading some textures, so these aren't really in any particular order, but inside a plugin. So yesterday I added I've got some textures, an albedo and a normal map. The plan was to figure out the best way to sort of set this bindless material system up. And firstly, we need to get a material to load a texture, create a material, and then what was happening is this material is actually crashing. So the size of the data expected by, let's see, size of the data expected by the texture create function versus the size of the data in the load texture from file was different. So what we really need is, so the thing is, materials can be shared amongst different entities, because we don't want to load and create all the textures from file. So this one actually starts to make less sense. Material info. I did make some notes actually. Okay. So this was where I got up to yesterday. I actually did stream this start of this to know people, but it didn't record. I didn't know you had to record manually. So this is kind of just to give the rundown again and pick up where I left off, and also kind of review the main reason I did the first one. I just wanted to make sure everything sounded all right, looked all right, and that it was kind of like legible. So the basic plan was to draw a C buffer per entity. It's going to have a world matrix and it's going to have a material ID. I currently have a way of doing that via push constants. But I decided to go from a C buffer approach. So then I could look up the C buffer in a bindless array of C buffers. So each, and I don't know if that's an efficient way. I hit a limit with loading. So trying to do instances in a C buffer, you hit a limit where you can only have 64K bytes of data in a C buffer. So I was like, that's a bit of a limitation. So what I was going to do here is try and have a C buffer per entity, which contains a world matrix and a material ID. And then we can have shared materials, which are looked up by the entities in the shader. And then, so we have a C buffer per material, which has the indices of albedo, normal, subsequently metalness and roughness. And then we can load those textures in ECS. So that's kind of where I got up to. So what I really want to do is go, I'm gonna spawn an entity which is going to have this material effectively. It's not really going to do much else. This actually, I don't need this material info, to be honest. Um, so this is just simplifying. Oh. So what's this going to be called? This is called metal grid. Metal grid. And so we can just spawn material. How does it know? It's fine just to do that. I think that seems like it's done all right. This is going to crash though, I suspect. There's a bug in the image loading code. Yeah, okay. So data size does not match the expected size. Massive calculator. Okay. The data size in here. This is the data size of the image. I know that they're 2048. Yeah. So it's not got an alpha channel. And it's expecting an RGBA. This is going into the kind of core lib now. It's a bit annoying. There's the plugins and then there's the core lib, and Rust Analyzer sort of struggles across the both. So image load from file, essentially. Because I don't think there's a format, an RGBA 8 format. There's BGRA. BGRA X though, so it is expecting. Right, so that's image right, load from file. Require comp. Basically it's saying, I'm saying it requires RGBA, but it doesn't. Actually one might do. Often I'm having to run outside of debug, because if you're trying to do hot reloading in debug, the PDB becomes locked and can't build. So there is a bit of switching sometimes between debug and kind of a client build, which is hot reloadable. Also, I'm having to build with one optimizations because of a symbol export limitation. And so, to be honest, I've got, it is a bit annoying. I actually got useless information. Right. Let's go. Just do something. Right, back. Okay, so just have to resort to a little bit of printf, which is a bit annoying. Yeah, components is 3. So basically we're saying that ain't good. So what we need to do is say if components is 3 less than 4. Now I'm doing Python style. Oh, components is less than 4. No, I'm going to handle explicitly 3. And I'll say else if not equal to 4. Panic. Hotline RS image. Okay, so a little warning to my future self. I don't even think you get RG formats or R single. Maybe you get single channel, which a single channel would be all right, or 2 channel, but 3 channel is not good. So this copying data. So this is just a straight copy. And for this one, we just have to do horrific component wise. I mean, this isn't supposed to be super fast path, but I have to loop over the data. data out, img is the data. Okay, so we have to just fill img data for x, for y, for x. For I in 0 to y, for j in 0 to x. So we're iterating over. It's a mult 8. Let linear position is I times height times comp, which is 3, plus j times comp, add alpha. So we get the linear index of the image data. And then obviously we have, we know comp's 3. That doesn't matter. For, gonna go for the full IJK. So we can go data out resize it always, and then we can go linear plus k equals img linear plus k, and then we go data out linear plus 3 equals 255, right? Grab that as a U size. No need as U size. Okay, so this is, God, so I can't index it as a raw pointer. Cannot index into a value of type pointer mutate. Beautiful. Offset. ref. What is it? A U size one. Oh. Add. So an add. Right. Well, let's go. So when it builds, if it changes the core engine or the core lib, then the plugins have to rebuild. There's an example plugin. Right, it's in here, that's all right. So my data size needs to be 4 actually. And my indexing, source linear, and then DST linear. So my source and my destination are obviously different, need to be different. Linear. So my source linear, and my DST linear. DST linear. Right. Building, come on. So yeah, again, back to slow build times, 10 seconds there. Right, brilliant. That doesn't crash anymore. Obviously, I can't really do anything. I don't have textures in there because that's in the core engine and I'm just doing it in the plugin at the moment. What we can do, let's go back to draw RS, load texture from file. The objective is to just get some visual representation. So I want to change these, I want to change their shader, and I want to get them basically being textured. And that, I think that'll be a good step in the right direction. So we spawn a material into the ECS. Somehow I need to know what material is going to belong to what. And there is a little bit of work I did before where I'm assigning parent IDs for instancing. So parent, we do spawn. Needs to be a batch. So I think I can get rid of material info. Material already is a bundle. See if that compiles. So there, I'm just trying to get the ID of the parent so that when we build a draw call, yep, that's fine. When we build a draw call, we can get the material. Maybe we don't need it because it would be better. So you just need a material instance, which is going to be albedo. I believe they're going to be U sizes, which is maybe not actually. I'm going to go with U32, albedo and normal. So what this is going to be is the actual handle to the index of the shader resource view to which I can obtain that in the shader. I can then push these into push constants. So material instance, I still need to keep a spawner material so that something is holding on to these resources if they're part of the entity component system. In future, those materials could move elsewhere, but that's what part of this process is, just feeling out how things should fit together and what's going to be the nicest way to do things. So we can create a material instance. My albedo. So we've got matte albedo. That's a texture. I'm not getting very good autocomplete here. That's because I've got two projects in the same, two cargo workspaces in the same VS Code instance. So I can fix that by opening the plugins separately, but that also has some downsides. These need to be public. Still failing. Last failed. Build failed. Albedo type on entity commands. Matte. Sorry. That's the wrong thing. Metal grid is where I should call it on. I think I can clone that in there. Or do that last actually. And just moving the metal grid into metal grid, and that was wrong anyway. Normal SRV index. It still failed. Right, these are new types, so that's always annoying to have to do the extra legwork. Oh god. And these are options. So we're assuming that's going to be okay. Still failing. This is the problem with Rust. There's so much stuff. Ah, right, inspected the U32 and it found a U size. So this is fine as well. I'm going as U32. It's still failing. Material instance. It needs to be a bundle. And then I need a new type for each one, I think. Oh, no, I'm just going to make it a component. And the component's small enough. This has worked now. Finally. So, here we go. I have a material instance, which is the shader resource view index of the albedo and the normal map. I have some spheres. Doesn't need to be that many, but the idea was I'll eventually add more materials. I need to now update it. So at the moment we're calling render meshes, grid wireframe meshes. These are my data files related to. I've got an itchy nose today. It's really like tickly. So it probably looks rude. The camera's ruining my nose all the time. So now in debug is the shader where I'm dumping a bunch of stuff. Now I created this shader. We have meshes. We have a pipeline, mesh, debug, C buffer, instance. That's not the right one. So I need a new one. Mesh, debug, C buffer. No, mesh, debug, push constant, material. I think we need to call it mesh debug. No, mesh debug, I suppose, is this debug shader. So I'm just going to call it mesh push constant material. So we're going to use push constants to set the draw call and the material properties, which at the moment are going to be limited, and that at least will get a starting point to kind of wrap this up. So if I can get something visual, I'll be very happy with that. So we still want a grid. I don't actually want wireframe in this instance, so that's fine to not have the wireframe. The meshes, pipeline, and function needs to change. I don't have a pipeline yet for it. So what have we got? Mesh debug. Well, let's take mesh debug and sort of inherit from that actually. Mesh push constant material. It's going to inherit from mesh debug, and it's going to specialize it by doing it. It's going to have a new VS. It's going to need color. VS mesh push constant. These are quite verbose names, just so they're like really clear. I'm gonna have two lots constant, view push constant, mesh material push constant. Currently I don't have much space for many more push constants, so I can just about cram in 4 textures, I think. The PS is going to be PS mesh push constant material. So I've got 2 shaders to add. But this is going to be mesh push constant material. Render meshes. And it needs this. So we're missing punch constant material in the shader compile, which I can add now. VS Mesh. Draw punch constant. So I need to alias this. This is going to be called material punch constants, and I'm going to use uint4 for that. Unit uint4 will matrix draw color material push constants, and in here they were called material push constants already. So then I'm going to have a shader which is similar to VS Mesh. Call it again. VS Mesh push constant material. VS Mesh push constant material. Same input, or matrix transformation, same. My outputs, my text coords might be different. So let's pass through. We could sample. We don't have to necessarily do that. So let's say color. I'm just going to say color is white. It doesn't matter for now. And then I'm going to also say main board. This one. Yes, mesh push constant material. The color's going to be white, and it's not really doing much. Oh, here we go. Get none 32-bit values. So uint4 hasn't been hooked up. That just needs adding to PM effect. Okay, so half and all of that. Half 4. Right, what is a half? How many bytes and a half? It's 2 bytes. Half 2 is 4. Half 3 is 6. Half 4 is 8. And int is 4. Int 2 is 8. Int 3 is 12. Int 4 16. Uint same 4 8 12 16. PMFX pipeline. That's interesting. Dependencies. The dependency actually doesn't have PMFX pipeline down. Included files. File in included files. These are dependencies, so it knows what to build. It knows to look in here for pmfx.py, but not for pmfx pipeline.py. This file. To dependency set. This is gonna work. It's not gonna. So this file itself is also a dependency. Saved that now, but it won't know until I make an edit. Error. See if this triggers a rebuild. Nope. That's another thing too. Like redefinition of world matrix. Actually, indices. Material world matrix. Let's do material. Material world matrix. There we go. Let's compile. Currently, still not doing anything. So we've compiled the shaders. I've got the new ones. And now I need to hook them up now into code. So basically, I'm using render meshes function. I need to actually change the render function. And that's going to be by that. But I also need to add the render function. So debug PNFX. Mesh push constant material pipeline render meshes push constant material. This is going to go into the plugin BCS demos render meshes C buffer instance render meshes pipeline colored. Render meshes push constant material. This renders all scenes in scene meshes with a pipeline component. Don't want that actually. I want that to be material instance. So the material instance component. And using push constants. Texture IDs. So we're already pushing matrix and a color, set render pipeline, and camera. That's actually going to do once per pass. Which is the same as render meshes. Debug, get pipeline for format. And that's the views pipeline. So here, the material push constant is the material we want to bind. No, I'm just going to call it pipeline. That's pipeline, then we bind the camera. Then we don't need to do a pipeline per mesh color, which we don't want. world matrix, yes, mesh, material, mesh draw query, material. So then material, going to push a couple, one material push constant. I'm going to push one, which is going to be albedo, which is a U32. And I'll push another one at an offset of 16, which is the normal. So I'm pushing in the world matrix and the albedo index and the normal index into the shader. If I run this now, failing. Material push constant. Material. Private field. Raw private fields. These need to be public. Expected a slice. Found a U32. You can actually do it in one. So we're pushing two constants. And need the reference to it, I don't think. Right. So now I've got the render function. Now all I need to do, I need to register this so it's accessible and I can, this client can find it within a DLL. This is a little bit of a manual step. I really want to be able to make a bit more ergonomic. Query. Not doing an instance buffer with a mesh component. A world matrix, a mesh component. So first, world matrix. Zero instance. Failing. So there's a bit of an error-prone step. Mesh component. It's compiled now. So everything's hooked up for me to now just change. So what did I have in the PMFX? This is the render graph, mesh push constant material, which is going to use that mesh push constant material pipeline and render meshes push constant material function. So if I go in the draw module, which has all of these examples, what I need to do is this function creates the schedule. The render graph is using mesh debug. Mesh push constant material. Self draw C buffer material. It's called C buffer material. It should actually be push constant material. Right. This one often happens adding a new shader. If I run it again now, it's going. I'm pretty sure it's going to work. Okay. The parameter is incorrect. I knew I wouldn't get it done. Now it's hanging. So the parameter is incorrect. I need to run a debug build. And I can get the D3D validation warning. And then once I've got that, I get to fix it. So, yeah, I think the expectation of that working was always going to be slim. Especially in adding a lot of new stuff. Always sort of something goes wrong. I've tried to fix it by adding error messaging and root signature exceeds maximum 64. Yeah, I've had this before, but the problem is I don't think so for starters, see what what EMFX is generated. The debug shader. It'll be the pipeline. So PFX generates a descriptor layout based on the usage in the shader. Mesh, push constant material, push constant, view and material push constant. And then the descriptor layout. It seems wrong. Push constant 48 on slot 0, slot 1. We've got 28. Whereas the test shader for blending uses color. Front view and draw. Blend disabled. Number values. I've done it all wrong. Get num 32-bit values. So num 32-bit values. What? I don't think you can have halves in there then. 1, 2, 3, 4, 1, 2, 3 and 4. We run again. Missing. This is incorrect. It's not. Oh, it's not detected the change to that. PMFX pipeline. Everything's up to date, so it hasn't rebuilt. And I have to touch that file. And so now I've got PMFX shader in there, and maybe now. Cool, there we go, white. So a little bit of teething problems. That's what this is about. Over time, make it easier and be able to do more without crashing or introducing kind of new functionality required. But anyway, I've got white material and a shader which is hooked in. So the final step should be, hopefully, the fairly simple task of adding a binderless texture set. See, I've got an example. This one's all packed in here, so it's kind of disgusting. Constant buffer. So we've got texture 2D. Textures. I'm going to call it textures. I don't know how many I have. I think these can be unbounded. There we go. They're not used yet though. When PMFX builds, it can detect like what the shader's using. That's why you can kind of alias registers and stuff in different shaders, which can become a little bit confusing, but also it's handy just so you can kind of keep working in a single file. That's not the right one. So push custom material, if I do this, basically just sort of void an operation. Right, here we go. Parameter is incorrect. So the problem there, we're going to have to go back to like spewing out messages. Root signature exceeds maximum 64-bit. Oh god, right, so tables cost 1 each. So I can't even add a new table in the root signature. But I'm not using view matrix, or I'm only using view projection matrix. I think I'm good to just remove these for now. So that is quite limiting the amount of push constants that you can use, because they're quite useful. You know, push constants are really handy. Okay, but now my guys are messed up. T0. Yeah, that should be fine. Might go bounded. Ah, I'm not binding the got some debug warning there. Just build the shaders. They're all right. Debug build. So this is spewing out now my 32-bit constants. The currently set root signature declares parameter 0 with type 32-bit constants with 32-bit value 16. Ah, that's going to be a massive problem to all of the draw calls in the ECS. Right, here we go. Needs, must. I need to bind the heap as well. That's another thing. I think all of the render functions are in here, and at the moment, what do we have? This is just 16, and it's just starting at view projection matrix. So all only setting 16 indices and only setting the view projection matrix, which saves me a good amount of push constants. These are 4x4 matrices as well, which they don't need to be. So yeah, there could be 3, but some of them can be the view projection has to be, but the view matrix could be a 3x4. Keeping those precious push constants. They are precious. Now, okay. Actually, let's go in. Oh, hold on. Render meshes, push constants material, and on firstly, I need to say set render heap. This is annoying me. This one basically the same. I actually set that on slot. Oh no, I'm not sure what slot it's supposed to be on. So in the default shader heap, which is created with the device, offset at 0, on slot, well, we can have a look at the output shader. Push constant material, descriptor layout. There's a binding on 0. I don't know if it's going to like this. It's a little bit confusing, the binding on the slots faces and kind of how push constants alter the position in the descriptor layout. Damn. Got the reference. fruits. This has to be the first one. That all references. Come on. Debug it. Don't take me to that stupid little window. I don't want to go to your stupid Visual Studio VS Code warnings. It's fine in here. Yeah. We call it device. Device. .0. Get shader heap. And by my thinking, I think it's going on 2, which doesn't really make sense. If you think of it in some ways. Built. Oh, it's working. Right. Okay. And no spewing out messages. So, right, the thing I was talking about, just to kind of maybe shed a bit more light on it. Right. I've got a sort of unbounded bindless texture array bound on register T0. But I have B0 and B1 of buffer of constants, push constants in the root signature as well. That means this is 0, 1, and 2. We're binding on the position in the descriptor layout, not this register. So then what I'm not sure about is what are these registers even being used for? Maybe they're not even necessary anymore. But anyway, we've got that. Luckily, I'm on an NVIDIA GPU, which is pretty resilient against doing pretty stupid things like indexing incorrectly into bindless arrays. So then push constants material, pixel shader, I need a sampler as well. But I can do a direct read. I'm just going to do a direct read. And I have a shader which is doing that without a sampler. Just for convenience for the time being. It's in draw. So, PS blit texture.load. Oh god. I need to know the dimension of it. And I don't know uint albedo textures albedo. We've got a text chord. I know the sample. I know it's 2048 by 2048. Keep that to float. Int 3. Call it video index. And I'm just going to call that albedo. Output color equals albedo. Let's. Ooh. Now I'm in debug. Albedo index. Right, they've gone black, so I am sampling something. Now I need to just get the thing from the texture indices. I don't need albedo in texture indices .f. Come on. Reload complete. That hasn't worked. Oh wait, there's something. So, what is this? That kind of looks like my texture data, but even if I sample 0, there's something in there. The image data could be completely messed up, to be honest. That's one thing. Let's see. We can load at record. Okay. So here we go now. This is time's getting on. I wanted to get something kind of wrapped up to finish off, and then go and get some lunch, basically. But look, I've still got a bit of time, so here we go into the next phase, render doc. Yeah, render doc is just such a good tool. You've just got to say fair play. Can't remember his name, the guy who made it, but industry standard almost. Right, let's see. Texture viewer. Query heap, buffers, command list, textures. Texture 2D. 1. Okay, let me look at it. No. Viewer. um, 2048, RGB8, U norm. These are the ones. 3. Oh no, 1024. 225. 229. Buffers, command list. Shader resource views. Right. 255. Can do something like in the lib, in the draw call, material. Material reference, material instance. I'm just going to do something like, I'm going to print out the material while I'm here because of the unreliable debugging video. Not that one. One of these should be the running instance. No, that's my PM. That's my GitHub action runners. It's still running. With render doc dealing the output. Come on. Right, albedo is 5. Albedo is 5. Normal. Come on. Normal is 3. Right, so we've got 3 and 5, basically. Could be also my UVs. You know, I'm not wrapping or anything here, and I know, actually, that could be another thing. So maybe the sampler thing is just going to be a bit more faffing around. I want us to just see the texture and be like, cool, it's loading, I'm indexing it. Cool, like, then the next one will be sorting that out. I suppose I'm almost there, but it's just not that satisfying having this weird sampling. So input text chord, I know it's multiplied by 3. Right? I keep wanting to do let. Like, I wish they had auto or something. T3 input text chord xy divided by 3. So I multiply it by 3 because it's roughly pi for wrapping for the UVs. So that's one thing to be mindful of. And it might need to be abs. We'll do abs. Right, okay. That's, you know, it's kind of, oh, let's change that back. That's a mistake. Go back. It's going to be back. Actually, it's back. This looks like that is how the texture looks. But like the pitch is wrong, which could, to be fair, be from my bad texture loading. So I know what I'm going to do. I'm going to load a texture that doesn't break. Here's my basic textures. I know these checkers were working. And this bear. I'm going to do the bear. Wrap him around the sphere. So debug raw. Okay, so quickly change these. There, stomp anim 001, but he's not. He's not 28. God, he's a strange size with these. 512 blue. It's going to be blue checker. Safety. Blue checker, and then what I'm going to do is also change this. Save all. That's the shader reloads complete. Oh yeah, that's working. Right, so something's gone wrong with my code that's creating the texture. But basically there is a blue texture. I know they were checkerboard before, but you'll have to take my word for it. Maybe I'll change it to the bear just for fun, and then that will really prove what was his weird dimensions. Properties 1783. And thanks Nvidia for making like things not crash. You know, it's so much easier than like having GPUs which do crash when you access out of bounds and things like that. It's just a lot of work. It's already a lot of work doing transitioning and all of that. Okay. It's him. I think that the straight up read. Let's see. This might go to 2048, do you think? If I'm just doing a raw read. Yeah. Okay, so there's the read chords, and obviously he's upside down, but cool, that's a texture. Yes. Right, that's it for now. I'm starving. I'm gonna get food, and then I'll do another video another time